number 18 for this differential equation, and the question asks to find a general solution to this. In order for us to find our general solution, we gotta get y equal to our homogeneous equation and our particular equation. So to get my homogeneous, I set my y's into r's and I factored it, and I got a multiplicity of 2, and my r equals -2. So I have my y1 equal to e -2x, and then because my multiplicity, to add on an x. So moving forward, this is my equation for the homogeneous case, and then I split up these two equations, but I noticed that I might not need to do that, because what we can do is, for my particular equation, which will be a constant in front, that we gotta solve for the constant in here, I noticed that we could just factor out the e to the -2x, and if we do that, we factor it out and get u1 prime plus u2 prime x equals 0, minus 2u1 prime plus u2 prime, let's put the little prime here, and then we have this left over, and you can see this is from factoring out the e to the -2x from here. You're left with 15ln(x) and all the rest. So I'm going to use Cramer's rule, and I get this. And to solve for this, multiply 1 by 1 minus 2x, and then subtract -2x, which is positive, which these will cancel out, which I'll get 1. This will equal to 0, and I just multiply the x over. This is 15ln(x) plus cosine x, and I get that. As you can see, there's no work here. And this part comes down here, and this part comes down here. So I solved this part first, right over here with partial. By integration by parts, not partial, my bad. And I got x sine x plus cosine x. And then I solved this also by parts, and this is what I got. And we can split these two, this up, integrating u1, and my final answer is this right here. My u1 is equal to that. Now solving for my u2, use Cramer's rule again. And if you notice, the only thing I changed from here is I lifted this up and I slid this to the side. It's a cool little trick to remember. But you get this, and you already know that this is 1 from our previous calculations. So 1 times that, it's going to be basically that, and 0 times that, 0. So moving on, my y2 is going to equal that. And then we integrate my y2. Once again, I break it apart, I take out the constant, and pretty simple integration. y2 equals 15x ln x minus x, my cosine sine x. And now, if we go back a page, we see that our particular solution, u1 is multiplied by our y1, plus u2 multiplied by the y2. And here's my y1, y2. So we go to multiply my e to -2x by my u1, my u2 by x e to the -2x. And it turns out to be a very large equation, getting fit on the line, but this is my constant. This is my homogeneous equation. Plus, I have the plus right here. This is my u1 multiplied by my y1. I just took the e to negative 2 and I moved it down, which we can do that into the denominator. And this was over 1/2, so comes 4. Then plus x sine x plus cosine x, and then this is going to be my y1 times my u2. There's an x here. That was the x from right here, and that's sine x and x. That's my final answer.